Hi, it's Will from StormTheCastle.com, and in this tutorial I'm going to show you how to make a small telescope, a real telescope, with a lot of found parts and just some basic materials. It's not that hard to make. The most difficult thing about this is understanding the optics, and I will give you some guidelines to understand the lenses and what lenses you can pick, and you may be able to even use a magnifying glass. And if you've got some lenses around the house that you want to check out, I'll show you how to check those out to get the focal lengths on them so you can use them in a telescope. So let me go over the parts you need. You need some glue, some couple of pieces of corrugated cardboard like this, a couple of squares. You need two tubes, one that fits inside the other. And with the Christmas season, right now when I'm making this video, you may be able to find plenty of these. So this is how your telescope's going to work, and this is how you'll focus it, like this. But if you can't find two pieces of tube like that fit inside each other, you can cut one tube apart and actually cut it, overlap it a little bit, and then tape it so it'll fit inside another tube. And these are a paper towel holder. These are paper towel tubes, so you could use paper towel tubes if you wanted. But just slice it, fold it slightly over so that it will fit inside like that. Some of the other materials are you're going to need a scissors, an X-Acto knife, a pencil, some glue, and some paint if you want to paint your telescope. And I have my almost completed telescope here. They're all painted and almost ready to go. I'll be mounting the lenses in that, and I'll show you that. And mine is a 6-powered telescope. So, the important thing here is, the two real important things is, one is the little rings that hold the lenses in your telescope, and the other is selecting the lenses. And I'll pop in a graphic to show you, to give you a good idea of how you can select some lenses for your scope. I bought these online. They cost me $5 each, so it cost me $10 for these lenses. And there's a wide variety you can use. They don't have to be the same size, but you do have to have two lenses of different focal lengths, and I'll explain that to you. Trace a circle on your cardboard, your corrugated cardboard, just a little bit smaller than your lens, and then cut it out with an X-Acto knife, like this. Now if you cut it just a little bit smaller, you can actually get that lens right in there. Because of the corrugation, that lens will pop right in there and stay in place, and it's actually kind of nice. It's difficult to get it. It has to be just a little bit smaller than the lens. But see, I have that lens in there. If you can't get it, then just make the hole the size of the lens or a little bit larger, and then you can just put a little bit of glue on that to glue the lens and hold it in place. And do this for both lenses. Next, we will cut the ring around this to the size of the tube, so we can glue that right into the tube. And you do this for both of the lenses. Now, the easiest way to make the adapter ring is to make it just about the size of the tube. So what you can do is you can glue that right on there like that. And that's the easiest way to do it. You can also tape it if you want, or just glue it right in place. If you want it to look a little bit better, you can actually make the adapter ring smaller, so you can gently squeeze it right inside the telescope tube like that. But that's a little bit more difficult, and it'd be difficult to keep it lined up nice and straight. So you can just make the ring about the same size as the outside diameter of your telescope, and then glue it right like that. And the rings will be different sizes because you have one tube that's a little bit larger than the other. So custom measure and custom cut them. Okay, my telescope is complete here, and you would move it in and out like this to focus it. And let me see. What I've done here is I've put the long focus lens, mounted it in its ring, in its cardboard ring, and then put it on the larger shell of the telescope. And then I put the short focus lens in its cardboard ring and mounted that to the thinner tube of the telescope. So you glue those on to both ends, and you've got a telescope ready to go. Okay, let me walk you through some of the basics here of the lenses that you're going to use to make your telescope. You have two tubes, one that fits and slides inside the other one so you can focus this telescope, and you have two lenses, one on each end. Your objective, the light gathering lens, should be between 8 and 14 inches of focal length, and your eyepiece lens should have a focal length between 2 and 4 inches. Now you can use a lot of different variations for the diameter of your lenses. I recommend you go with a lens somewhere between 1 and 2 inches for your objective, and I used about an 1.5 inch lens. Mine's an 1.5 inch. And for the eyepiece, you can use the same diameter lens, or you can use this one that's half the size, or even smaller. So if you do a 2 inch here, you can do a 2 inch here, or a 1 inch here. If you do a 1 inch here, you can do a 1 inch eyepiece or a 1/2 inch. Now let's talk a little bit about the different types of lenses that you can use. The setup that I used is a simple, very simple setup. It's a double convex. Each lens is double convex, curved on both sides. And a little bit better of a telescope would be a large double convex for your objective, a smaller or a half-size double convex for your eyepiece. Now, if you want to make a telescope much like Galileo's telescope, you could use this kind of a setup. You can get a lens called a convex-concave lens for your objective, and a plano-concave lens for your eyepiece. And this next setup here shows a large objective and a half-sized eyepiece. Now, if you only have one lens, say a magnifying glass or something like that, you still can make a telescope that works pretty good. You use your double convex lens here from your magnifying glass, and you actually use a pinhole here for your eyepiece. And the best way to do that pinhole is stack up 5 or 6 pieces of aluminum foil and then carefully pierce a pin through them all. And then look through them and select one that has the roundest hole. It has to be a very small, very round pinhole, but it has to be very round to work effectively. And then you can use that pinhole and mount that on your telescope and look through that, and it will actually work. So you can actually get away with making one of these telescopes with just one lens. Say you have a magnifying glass. So, let me just say a little bit about magnification. You want to know how the power of your telescope, you just take the focal length of your objective, divide it by the focal length of the eyepiece. In my case, my objective focal length is 30 centimeters. The eyepiece is 5 centimeters, so I divide it, I get 6. So if you want to order lenses and you want to get some magnification out of it, say you want to get 10 magnification or maybe 20, I wouldn't recommend going higher than 20, then get the correct focal lengths. What I want to show you here is how to find the focal length of the lens. And you know now that you have to have 2 different focal lengths for your telescope, or you should. One long focal length and one short focal length. The long focal length being the objective, the primary lens, and the short focal length one being the eyepiece near your eye. And so this is how you find the focal length. Get yourself a light source and place it as far away as possible from your you, like across a room or even down a hallway, or better yet, if you could even use a window, the light coming from a window, or a street light outside, or even the moon. But the important thing is the farther away you get it, the more accurate your reading will be. Ideally, you would use a light source that was infinitely far away. But get it as far away as you can, and it'll be good enough for what we're doing to find the focal length of the lens. And all you have to do is take that lens and bring it next to a wall or a piece of paper or even an index card and move it back and forth until the light source is sharply focused. It's going to be fuzzy until when you get to the right distance from the wall, it's going to be nice and sharp, and then measure the distance from the lens to the wall, and that'll give you the focal length. And use that to make the dimension of your telescope. And each tube should be about 3/4 of that distance. So let's say this came out to 10 inches. So make each tube about 7.5 inches, and then you can overlap them and find your focal length for focusing. So here, and I'll show you a close-up here of me focusing. I'm using one of those high-efficiency, energy-saving mercury bulbs. So there's my focus point. So it goes out of focus, it gets fuzzy, and then it gets nice and sharp, and you can see the bulb really nicely there. So now measure the distance from the lens to the wall, and you've got your focal lengths of your lens, and you know how big to make your telescope. And this is a magnifying glass that I use. So if you get a magnifying glass, check the focal length on it, and use it in your telescope.